Think like Tesla.
Think Like Tesla, Micah here. I was planning on talking about electrical safety this week because there's going to be some electrical things coming up, some nice high voltage experiments, sparks, and that sort of thing. But I am obsessed with trying to get this gizmo working. Yes, I took a Nintendo Entertainment System NES and I'm turning it into a ham radio. Only problem is it doesn't work. So this board here is a Microbit X, recently featured on Nuts and Volts magazine. You can see the blocking some of my light here, but you can see the pinout diagram, see the block diagram of all the pieces in this. So good stuff. Unfortunately, this model that I got, this revision of this board, also has this problem. Now, if you don't recognize that, that's a TDA 2822. It's an audio amplifier chip. This one in this picture here is completely cracked in half. Mine didn't do that, but it did fail to work. So I have a replacement chip in there, and I'm working on it. So when I power this guy up, I don't know how much of that you can hear. Some kind of feedback coming in, and the LCD is not reading the right display. Very sensitive to movement. So I've been disconnecting various wires, trying to figure out what's going on, adding shielding to various wires to see if I can eliminate this feedback, trying to strip it down to its most basic problem. Boy, that's annoying. I'll turn that off. And that's how troubleshooting goes. Let me work on this a bit, and we'll see where we get from there. I have made an amazing discovery. I was about to take this oscilloscope probe here and try to measure signals at various points. And when I connect this ground lead to my star ground terminal here, with my tongue at the right angle, that's interesting. With my tongue at the right angle, still getting some kind of feedback, but when I'm not, it's a scratchy sound, kind of like a radio that's not tuned in. So, narrowing it down. Onward. Okay, here we are after tearing this thing down and rebuilding it. You can see the wiring looks a lot neater. They are twisted together here. What happens when you twist wires together is that any interference that comes through one wire comes through the opposite wire with the reversed polarity, so they cancel each other out. So that should be a lot better. I have a choke here. Can't really see it on my camera here, but I have a ferrite choke on the power cable. And the thick ground wire that used to go all the way around back here to this connector no longer does so. It terminates in a wire here, which I'll probably just cut off. Now all the ground is truly starred here at this point. This is the central grounding point for the whole thing. Will it make a difference? Let's find out. Well, before we find out, let's talk for a minute about ground loops. 2 fresh 9-volt batteries. Jumper wire. Now I want you to think, what's going to happen if I connect this jumper across the positive to negative terminal from this battery to this one? Compared to the internal resistance of these batteries, which is on the order of an ohm or two, this is effectively a dead short. So if I connect this dead short from positive to negative, what's going to happen? Think for a second. What's going to happen is absolutely nothing, because these batteries each are what we call floating. They're not. There's no common reference between them. Do this. That's another question. So if both of these negative terminals were connected to a common bus, say earth ground or even just a common wire, then connecting positive to negative would be a short, the same as if you did it on one battery or the other. So if something is floating, that can make a big difference. So here's what I think was happening in my radio. All right, is that readable? So here's the U-bit X. This is what I called a star ground before. All the points that need to be grounded come to one place on here, except for this one, where the main power connector comes in. That was also connected to ground. So you notice there's a complete loop here of conductor all the way around. Now, normally that would be fine, unless you think of it this way. Another name for a loop of wire like that is an antenna. So if any kind of noise is getting generated around here, this antenna will pick it up and it will actually change what is supposed to be the 0-volt reference. It'll change it, it'll wiggle it around, it'll move it. So anything else in this whole circuit that needs to be measured against this reference, since voltage is always relative from point A to point B, those voltages will seem to be moving around also. So that can cause all kinds of signals to get stuck in your circuit or bouncing around or doing all kinds of crazy stuff, like we saw before. So this is how I think we spotted the problem. Okay, this represents an oscilloscope probe here. Here's the main probe, which wasn't actually connected, and the alligator clip, which turns out is earth grounded through the oscilloscope. It was touched onto this point here. Now the power supply I use had one of these in place. This is just a piece of metal connecting the green and the black terminal so that the power supply was no longer floating, but was also earth ground referenced. So with the power supply earth ground referenced, and as soon as I touched this oscilloscope probe here, my radio was also earth ground referenced. That essentially created this line here, this dotted line, earth ground to earth ground. And that must have had a low enough impedance compared to this one to short out whatever was causing the feedback. So for the most part, I got silence when I touched that ground lead. That's what I think happened. So time to test that theory. All right. Got everything wired up the same as before, except I don't have the LCD hooked up. Antenna, I got 12 volts of power direct from my power supply, which is not earth grounded referenced anymore. And same headphones for the audio. We're going to turn that on and see what happens. Will it make noise? It didn't. My power supply spun up, 120 milliamps. Listening in here, I hear a hiss on the headphones, which gets louder when I turn the volume up. That is a good sign. That is a very promising sign. Now, making sure I have a speaker connected, which goes this way. If I unplug the headphone jack, I should get that same soft hiss coming from the speaker instead of the headphones. Or not. Alright, so that's something I need to continue looking at. But I'm noticing one other problem here also. There's two lights here on my Arduino. Actually, when you look real closely here, maybe that third one is lighting up a little bit too, but that's not good. The TX light is on. That shouldn't happen. And if I click reset, they should at least blink off a little bit. So, in addition to whatever else is going on, it looks like my Arduino board is dead. And I hope this little guy here, this little clock generator, isn't gone too. So one more thing to do. Fortunately, I have a replacement. So let's see what we can do with this next.
Teslanomicon.
After I went through this last week, trying to fix my ham radio, how could I recommend any other book than this? How to Diagnose and Fix Everything Electronic. Michael J. Geyer. This is a great book, especially if you don't really think of yourself as a repair person. It helps, like for instance, he talks a lot about the philosophy of troubleshooting. How to not get intimidated by a huge schematic diagram with lots of parts. A lot of it is just critical thinking, breaking down problems piece by piece. And yes, sometimes there's more than one thing wrong with your device, and you have to be persistent and keep at it. So I recommend this book. Check it out in the links below.